When it comes to CNC machining, choosing the right material isn't just a technical detail. It affects cost, lead time, and the quality of your final part. Whether you're an engineer, designer, or procurement professional, understanding the differences between aluminum, steel, titanium, and stainless steel can save time, money, and headaches. First, aluminum. Aluminum is lightweight, easy to machine, and allows for faster lead time. It's excellent for prototypes, automotive brackets, aerospace components, and consumer products where weight matters. From a cost perspective, aluminum is usually more affordable than titanium or stainless steel, and tool wear is minimal, meaning lower machining costs. Its excellent thermal conductivity helps reduce heat buildup, so parts stay accurate and maintain tight tolerances. However, aluminum is softer than steel or titanium. Thin walls can deform under pressure, and surface scratches are easier to appear. Chip control is important. Without proper tooling or strategy, long, stringy chips can slow production. In short, aluminum is ideal for high-speed prototyping, lightweight parts, and cost-sensitive projects, but not recommended where maximum strength is critical. Next, steel. Steel is strong, durable, and widely available. It's perfect for structural components, machinery parts, and tools that must endure heavy loads. For CNC machining, steel machines are slower than aluminum and wears tools faster, so careful selection of cutting parameters and coolants is key to maintain dimensional accuracy. The material is heavier, which can affect assembly or shipping costs, but it provides a reliable balance between strength and price. Steel is often chosen when part performance under stress or impact is the priority, and when lead time is moderate, not as fast as aluminum, but cost-effective for production volumes. Now, titanium, the high-performance choice. Titanium combines incredible strength with low weight, and it's highly corrosion-resistant. That makes it perfect for aerospace, medical implants, high-end automotive components, and any critical part where durability is non-negotiable. But machining titanium is challenging. It generates heat quickly, wears tools faster, and requires slower speeds and specialized tooling. That translates to longer lead times and higher cost, but the payoff is exceptional part performance and longevity. In short, titanium is the premium choice when part strength, corrosion resistance, and weight reduction are top priorities, and budget allows for high-precision manufacturing. Finally, stainless steel. Stainless steel is not as light as aluminum or as strong as titanium, but it offers excellent corrosion resistance and a professional appearance. It's ideal for medical devices, food processing equipment, marine hardware, and consumer products that require polished or brushed finishes. CNC machining stainless steel requires attention to work hardening, heat management, and tool wear. Cycle times may be longer, but the resulting part is durable, corrosion-resistant, and precise. Stainless steel is a great choice when durability, appearance, and corrosion resistance are essential, even if it takes a little longer to machine. So, how should you decide? Aluminum. Fast, lightweight, cost-effective. Ideal for prototypes and non-structural parts. Steel. Strong, durable, affordable. Perfect for heavy-duty components where weight isn't critical. Titanium, high strength, lightweight, corrosion resistant, the premium choice for critical applications. Stainless steel, durable, corrosion resistant, polished finish, excellent for medical, marine, or consumer grade products. At Yijin, we work with all four materials, delivering custom CNC parts with precise tolerances, high surface quality, and reliable lead time. Whether you're producing a single prototype or a small batch of custom parts, we help you choose the right material, optimize manufacturing, and get your parts on time without compromising quality. Don't forget to like and subscribe for more content on CNC and precision machining.